Welcome back to the Math Professors. Topics are covered in algebra, statistics, calculus, and so on. So if you like our free content, please consider liking, subscribing, and sharing. So today what I want to do is do applications of normal distributions, and I want to start out with the standard normal distribution and then talk about how this relates to a normal distribution with a given mean and a given standard deviation. So what I know with the standard normal distribution, the mean is equal to 0 and the standard deviation is equal to 1. Given me this bell-shaped curve with a cumulative area underneath the entire curve equal to 1. So a normal distribution has the exact same cumulative area equal to 1, except the mean is going to be given by some number and the standard deviation is going to be given by some other number. And what this happens to be is this is heights of men. Really, it's heights of men in the U.S. So I know the mean height of men in the U.S. is going to be 69.1, and we have a standard deviation of 2.9 inches. Okay, so what this allows us to do is remember that the standard normal distribution, we can use z-score tables to be able to find cumulative areas. So how do we find these cumulative areas for any normal distribution? Well, what I have to do is I have to be able to go from, this curve really, kind of back to this curve. So, these things are z-scores. And these are x values. So how do you go from x values to z values? Well, the way we do this is through a z-score. So, the z-score is going to be equal to that given x value minus the mean, all divided by the standard deviation. So that's how I go from this to this. Okay, so let's do just a quick example. So let me pause it. I'll write it down here. So here's my example. I want to determine the probability I have a height less than 73 inches. So really what I'm asking about this is, here is the normal distribution. I know the mean of men is 69.1, which I'm unfortunately nowhere near. But I want to know what's the probability that I am 73 or less. So 73 is going to be about right here, just a little above 72. So really what I'm doing is I'm asking for this cumulative area. I'm asking for the probability of, less than 73 inches. So really this is going to be my answer here. So in order to do this, I really want to figure out, what value on the z-axis is equivalent to this 73. So doing that, let's look at this. So my z-score for this particular example, or all examples that include this mean and the standard deviation, is going to be x minus the mean, which is going to be 69.1, all divided by 2.9. So any questions that pertain to heights of men is going to use this equation to go from x values to z values. Now what I want to do is I want to use an x value of 73. So I want to figure out what is that 73. So doing the numerator first and then the denominator second, I will figure out exactly what my z-score is. So that's going to give us 3.9 over 2.9, which is going to be equal to 1.34. Rounding to the 10th place, because that's what that's your table does. So what I have to now do is I go to my z-score table. Remember again your z-score table. This is your z-score, and I need to go 1.3 here, and I need to go 0.04 here in the positive z-score. And this is going to actually represent this area over here. Now the idea is that 73 correlates this 1.34. So that these two numbers, so this will give you this area on the heights of men, and this is going to give us the area of 1.34, which is right here. This is 1.34, and you can see that actually is located in a very similar spot. That I knew the heights of men have a mean of 69.1, and then over one standard deviation, over one standard deviation, and so on. So I can tell that this 73 is above one standard deviation, and that's kind of shown here, that there's actually 1.34 standard deviations above this mean. So that means 1.34, this pink area is going to be equal to this pink area. So I can use my standard normal distribution to be able to find the area of any normal distribution as long as I use, this z-score conversion. All right, so looking at 1.34, so 1.3 and then 0.04 is going to give me 0.9099. So let's do that in pink. 0.9099. So this is equal to 0.9099, which actually means this is equal to the exact same thing. So let me show you the the notation that we use. So what I'm asking for is, I want to know what is the probability that x is less than 73. I want to know that. Now it just so happens the probability that x is less than 73 is equal to the probability that z is less than 1.34. What this really means is that this pink area over here is equal to this pink area over here. Now I can use my table to find that pink area, which is going to give me that 9099 or 0.9099, or I can say that this is a 90.99% chance that I have a height less than 73. That really what it means is if I select any random person, any random male that lives in the U.S., what's the probability that they have a height less than 73? Well, that's the probability. So next I want to do, well, what about more? Let's just use the exact same numbers and kind of ask this. So what if I ask, what is the probability? Determine the probability a randomly selected male now when I say I should have said this, from the US, from US, has a height more than, let's use a negative one. So let's say let's go like somewhere in between here. Let's say 67 inches, more than 67 inches. All right. So let me pause it, kind of erase these things, and look at these associated probabilities. All right, I guess that's clean enough. So what I want to know is I need to know what about bigger than say 67 inches. So let's say here, 67 is going to be somewhere about in there. So 67 inches. So what I know is instead of this being 73, this is going to be equal to 67 now. So I'm going to have to find this particular z-score for 67. So we're going to get the numerator is going to give me negative 2.1. The denominator is going to give me 2.9. So when I subtract that, I get negative 0.72417. So rounding this to the second decimal or the hundredth place, this is going to give us negative 0.72. Now the reason why we round to that particular spot is it's all motivated by the table. The table always gives you to the 10th place. So what that means is that that this 67 over here for the heights of men is going to map to this negative 0.72, which is going to be about right here. So this is negative 0.72, and we can see that this is looking good. This is the mean, this is the mean, and this is between, one standard deviation below the mean, so it's exactly kind of where I expect it. So now what I have to do is I have to look at that negative 0.72, because what I'm asking for is I'm looking for this particular area. What is the cumulative, oh actually not the cumulative area to the right, I need to know the cumulative area to the, sorry, not to the left but to the right. So I'm looking for this. So very similar, I'm looking for more as opposed to less. So what's the probability that a randomly selected male has a height, greater than 67 inches? Now, let's kind of do the notation here and kind of talk about this. So, the probability that your x value is greater than 67 ends up being the same thing that your z value is greater than this negative 0.71. Now I know that my z-score table only gives me this area to the left, so I only know this area. So let's go ahead and find that. So this area in here is 0.2389, which means that this, well actually I should have said this is 0.2389, which means this is the same thing. Now I don't want area to the left, I'm looking for area to the right. Now since the entire things add to 1, I know if I'm looking for greater, this is going to be 1 minus the probability that z is less than negative 0.71. So it's, it's 1 minus this number, so this is going to be 1 minus that 0.2389, which is going to finally give us this pink area of 0.7611. So 0.7611. Or I can say that this is 76.11%, depending on how the question is asked. If they ask for a percentage, give it as a percentage. If they don't, then the decimal is just fine. So the very last question I want to do here for this particular section is, what about an area between? So let me erase it over here. I want to find the area between and talk about how we find this thing, okay? All right, for my last example, I want to find an area between. So we're trying to ask, what's the area between 65 and 67? Now, a quick erasing. So I want to be between 65 and 75 inches. So what I know is I'm asking for, this pink area to be between, 75 and 65 inches. So I'm already knowing that this should be above 2 standard deviations. So I'm assuming it's going to be somewhere around here. And this looks like it's less than 1 standard deviation, so it should be somewhere over here. So when I find their z-scores, I'm expecting those type of numbers. So let's go ahead and find the z-scores for each one of these. So the z-score for 75 is going to give me 2.03, which is what I expected. The z-score for 65 is going to give us negative 1.41, which is what I expected. So this is 2.03. This z-score right here is going to be negative 1.41. Now, in a previous video, I showed us how to find the area between for z-scores. So the way this is done, if I want to find the probability that 65 is less than x, which is less than 75, we know that this is the probability that their z-scores are between negative 1.41 less than z less than 2.03. Now what we're going to do is we need to find the area to the left of 2.3, which is going to give us this cumulative area to the left, and I'm going to have to subtract off this little left tail. So the way this is done is you're going to have to find the area to the left of that 2.03, and I'm going to subtract off the area to the left of this negative 1.41. Going to the table, I will find these numbers. So this area give me 9788.9788, and then subtracting off that left tail over here, which is 0.0793, is going to give me an area of 0.8995. So this is 0.8995. So again, this is 0.8995, which means that this is also that 0.8995. So again, if you like the videos, please consider liking, subscribing, and sharing. Thank you.